Okay, good afternoon. This afternoon, I would like to talking about welding and NET activity at the King Weld. The King Weld is stand for King is mean King Mongkut. So we come from the King Mongkut University of Technologies, Thonburi, and Weld is the welding. We one of the welding research in Thailand, and we are leading in a welding industry also. So to talking about this, I would like to mention a little bit where we are and who are we. Actually, we originate from the technical college. KMUTT is one of the technical school before we become Institute of Technologies. In 1980, we transformed the technical college to the university. It's an Institute of Technologies. And at the time, we originated, we call the Institute for Science. Sorry. Better, I can stand now. So, sit is not my type somehow. So, no good? No, like thing. Here. Now they can zoom now. Okay. So, the Institute for Scientific and Technical Research Service has been established. So, this one, we focus on the industrial service. For KMUT, we have this institute because we have so many industrial service. So they set up the organization that can contact with the industry directly. Before, we have to pass through the department. Now we have a research center to contact to do an industrial service. In 1998, we become the first university that become like a governing university that we get out of the system, become like an autonomous university or something. We are the first one. And for the King Weld, we established in 2006. We have very long story. We got some sponsor from the National Metal and Material Technologies, or MTech. We're starting from a research center, a small group of research center we call a plastic and composite joining at that time. We got a sponsorship to working on the research project on plastic and composite joining. And after that, we get continuous sponsoring from this organization to develop expansion in the welding industry, become like a metal welding and stuff like that. I will talk about it later, what we do. Right now, it's almost 20 years old now, my center. So what we do? As I say, we are the organization that contact with industry directly. So what we do so many missions. Our mission is, we have 4 areas. The first one, we're doing a training and certification. Since the welding industry is some kind of very strict on the standard, even on the qualification of the personnel to working on this industry. So we do destructive and non-destructive service. And we also working on the consulting and service. So many consulting work. I cannot talk in 20 minutes. So many work. And the last one, we also do a lot of research and development. We have a master degree and PhD degree in welding engineering, and the really first one in Thailand. And also we do working on the research in this area for some times. On the right-hand side is some example, what we done. That's only the training course that we provide every year. So like next week we have something to talk about it. We're talking about all the welding industry course. The welding process, material, behavior, design. We're doing a course on the construction design, structural design, pressure vessel design, piping design. Since our customer, most of them, they come from the gas transportation industry, oil and gas, power plant. They send all the people come to us to training on this kind of stuff. In the non-destructive side, we also have various of NDT training and certification. Most of the NDT application that we use, we have all of them. We have a pretty nice facility to working on this one. And on the last column, that's the code and standard that we're working on. If you have quick look, we can see that various standards like American Petroleum Institute, ASME, American Welding Society course, and even ISO standard. Since we contact with many customers from many countries around the world, so we need to know so many standards on this one. Talk about our staff a little bit. Since I can say that the welding industry is one of the very strict on the personal qualification scheme. Starting from the very worker level, like welders, they all need to have a license or certification. Going up, welding supervisor, welding inspector, welding engineer, they all have a qualification standard. On the railway system, same. Now, if you take a look at the standard, even the fabrication standard, repair, they are talking about qualification of the personnel. We cannot allow anybody go to working on something that very advanced, like Dr. Pirapong said. We need a qualified personnel. And we have people that qualify for the international welding engineer. In a non-destructive side, we also have a level 3 in the American standard in most of the NDT method that we use in Thailand. And we're also working on the standard on the aviation or aerospace industry. Since our customer that come to us, they also come for training and certification for like aircraft inspection or maintenance. And I think we are only one that doing this service at this point. See next. There's some activity. I just select some activity that related to the railway industry. This picture may be past year or something like this. So we're doing a training and qualification for the welders and welding operators. They're working on the rail. For example, the joining of the rail by thermal welding or flash butt joint welding, or even the training of personnel on the welding repair. Some of you might not know that the qualification, the people that making a weld on the rail, they have a standard to qualifying them, which is different. We're doing a qualification for piping oil and gas industry. They use ASME standard. For the structural construction, like a steel structure, they use AWS standard or something like this. For the rail, they have certain standard. Test sample, the test method, they are different. Material difference, skill different. The way that we qualify them is precisely set in the standard already. So this one is some sample from AWS that how we qualifying them. This is an actual company that send the people to us to train and qualify to get their certificate to repair. I don't know how many people in Thailand have that certificate right now to doing repair. And some of the activity that we do a procedure qualification test. Some of the company they use, for example, the new type of the termite powder to be used. That means you need to have a procedure qualification test or something like this. Go on quicker. Let's move to the non-destructive testing. A quick explanation. Some method that we often see for the rail inspection or any part of the car on the railways is like a liquid penetrant test that we use the liquid that have a really high contrast to see any discontinuity or defect on the surface. So this also needs qualified personnel. So as you can see on this picture, it's like a visible one and also the fluorescent one. So it depends on what type of the defect that you're going to see. Since this technique, they have different sensitivity to detect. It depends on what you're looking for. Some of the part, I can see here, that's a aircraft component. That's example. Another one that we often see is like a magnetic particle test. So you're gonna see it when they're doing a welding repair on that surface of the rail. As you know, the rail is like a palladic steel. It contains like 0.8% of carbon. That means without procedure that been qualified correctly, is more likely to generate crack on the rail. And in my experience, most of them didn't do it right. And they didn't do the inspection right also. That means whatever you see on that one, maybe they're not being tested properly. After the repair, they already originate a lot of crack on it already. See the example, they use a magnetic field. And later on, I will talking about the research on this one later. Ultrasonic testing, we use ultrasound. That's most common way to inspection. But if you listen to the yesterday presentation, all these inspection, they are changing a lot. This one is normally that we do. I think in the future, we're gonna change a lot of things on this one. I'll talk about this later. This is using a normal probe to inspection on the rail head and using the shear wave probe inspection on the web and foot of the rail. One of the popular one that's come into the project contract, and I remember the first time I went to the one of organization and asked me to review the inspection result on the phase array. Since they don't know that picture is interpreted correct or not, the phase array is what is simply is ultrasonic testing. But on the system, they use an array of the piezoelectric crystal. So this kind of technique, you can visualize the sectional view of the image. Before, on the previous slide, you can see already the time amplitude signal and interpret anything from this one, which is very difficult. And in the new technologies, not new, it's more than 10 years now, they're using a sectional view of this one. To be able to inspect like this, the inspector or qualified inspector, they need to be at least level 2 before. And they have to train like more than 2 weeks, like 80 hours of more training from level 2, and another hundreds of hours experience be able to interpret it correctly. And somehow, something like this is missing here. I know that because I qualify these people a lot and see the problem a lot, not only in the rail industry, also in the oil and gas industry. Another one that we use, we call the eddy current testing. This is one of the popular one right now because it's a non-contact type. The previous one, you need to contact everything with the rail to inspect it. For this type of thing, we use like a electromagnetic induction to induce the eddy current flow inside the material. If any defect inside, they're going to disrupt that flow on the sample. And we can detect the magnetic field that change, and we can measure the, we call impedance of the coil. Difficult because you got to interpret what make it change. Okay. The thing like this, you can see the coil don't even to contact with the sample. That means we can do high-speed testing. If you listen to just their work, a lot of things using these technologies. And we're working on the research on this one also. I'll talk about this later. So this is something that the trend in the inspection technologies come. Before, we mainly depend on the skill of the labor and labor extensive to work, which is takes a lot of time. But next one will be more speed, is like a semi-automatic. And the next step, it become robotic. Just there we can see that so many robots walking right now to do inspection. But robot it cannot replace us. We need to teaching them anyway. We need to done so many research to analyze all the signal that gets from the robot. For example, you can see something like this. This is like a wheel burn. And some damage might occur during this heating. With the fast heating and fast cooling, they can generate unexpected result on the material properties. For example, they make the rail surfaces more hard. That means it's more brittle when it's come into the contact. With the repeated load, you can see so many cracking, something like this. In my opinion, if it's something break like this, no problem. I can inspecting them easily. We have so various techniques to do it. But the trend in the future is that how can we detect before it's happened? That's our research in the fundamental fund. We can know when they're gonna originate. Not just detect what is happened to predict it. It's a trend in the world. In oil and gas industry, also same. We're working with them when we're gonna replace them, when we're gonna repair them. We need to predict them for something like that. It's like for life, we call it life assessment. They become like a more automatic and walking. Right now, they push all things like this to the inspection car. Just go with the trend. Now, you have to high-speed testing. So many technologies will come to doing that. Not easy. Now, talking about the research scheme in KMUTT a little bit. In our university, we subdivide into the research theme group. For example, one group working on the sustainable bioeconomies, sustainable energy, smart healthcare, innovative material and manufacturing and construction in one group. And we belong to this group, we call sustainable mobility. The real system is in here. Our group is in here in the KMUTT. Within our group, we still have an EV group, aviation, supply chain management, and transport policy and planning team doing a research. And the other one is the digital transformation. Let's talking about us a little bit. That's what we have, the research project recently going on. And we have so many projects in the future also. Let's see. Mostly what we do on the railway research. This is the input. That means we have a research funding from the many organizations that related to this industry. Research network with Professor Pilapong and many people. What we're gonna do in which area? So we get some problem statement from here. And for the research in the railway in KMUTT, in our expertise, we will focus on 3 major areas. One is product reliability and repair. That's one. We're gonna reliability and doing repair technology, something like this. Another one is we call manufacturing reliability. We're gonna build up local content. We're gonna manufacturing many things. How we can make it reliable. The last one is the railway product development. So from this theme, we send out the research proposal and get the funding from 2019 or something to get a series of the research project. For example, we're doing a research project on the quantitative surface crack assessment. We use many kind of non-destructive testing to evaluate or assessment crack. We're doing a research on the repair. In here, Dr. Sompon is head of the project is here. So we're doing a research on multi-repair. Since we got the project from the industry, like how many welding repair can be done on the rail. Since you repeated it and welding many times, what's gonna make it change? And we found very interesting result. That means you cannot do whatever you want anymore, right? The microstructure is changed a lot when you're making a welding repair. We're doing additive manufacturing on the frog rails. This material is like a high manganese material. We're doing a qualitative and reliability improvement on the aluminum weld structure. This is on the car body or something like this. And the last one, we do a prototype for the mechanical and electrical system for analyze power quality. This belongs to the electrical engineering, right? And for this one, our research output from this 5 projects, we will deliver for like 11 publications with 2 patents, and we have 24 research students working on this one. Just give a quick brief. I have maybe a few minutes left. So this is what we do. For example, one of the projects, just giving some sample. We're using electromagnetic induction to inspection on the railhead. We working from, we call the inversion method. That means we can inversion from the eddy current signal and can predict it, what is happening here. Both forward and inversion. Let's take a look. This is our research project. What we do, we can design all the sensor ourselves. Before we designing, we doing a numerical simulation, both the coil to induce the magnetic field. We simulate the defect in a simulator. We got what type of sensor we need. We build up the sensor. In the experimental side, we simulate what happened and actually comparing between the numerical and experimental result. As you can see from this picture, we moving the coil to the simulated defect, and this is what signal we're gonna get. Actually, we measure the magnetic field both in X, Y, and Z direction and see what kind of response that's going to happen when eddy current moving through the crack. You can see this one. See it a bit. This is actual result. When it passes through it, you can see all the signal. That's crack, that's crack, that's crack with different depth. This means we know that it's going to respond something like this, but we don't know what type of sensor sensitive enough to detect them. We detect both in the transverse to the direction of the movement and also in the longitudinal or parallel to the sensor. Pretty nice. And we can see what type of the magnetic field in Z direction and in X direction, which magnetic field we use to evaluate it what. That gives us idea to build up all the sensors that's going to put on the inspection system. This is actual result. We can write all the software to display them nicely. When you inspector can see them pretty nice, what happened, like a visual image. That's the simulated defect. That's actual defect that we test on the rail. We can mapping something like this, pretty nice. Little bit. This is testing facility that we have. We got the funding from the university to set up the testing lab for the rail. For example, we have a 3,000 kilonewton compressor tester to test a slope and test. We have a repeated load with a 250 kilonewton that can operate from 1 to 20 hertz. And we have a universal tensile machine, hardness tester. All this equipment, actually we decide to test on the rail. But actually we have more equipment than this because we need to do a metallographic testing, something like this. That's what we already have. This is qualification standard that we can be done. We already get past the audit to certify to ISO 17225 test standard. So that approval test like visual, NDT, band test, macro and microstructure test, hardness test, and also fatigue load test. That can be done in KMUTT right now. This picture just took with Kun Sombat last month. That in the future we're doing like a consulting work and working with industry to develop many kind of testing and inspection technologies. Since this is, I think, it's the target for the rail industry. That's what we want, and we need to develop based on the demand from the industrial side. Maybe that's all. I make a quick presentation. We have very short time. Many interesting on the railway. Just final conclusion is that, as you can see, whatever I talk today, they got a standard with it. Starting from the personnel, the method of the manufacturing process, how we make a quality control on the construction, how we gonna test, what standard we need to be test. That's all we need to study, right? Okay, maybe I finished my presentation today. Maybe got some question from the floor. I have been asked to present general information. So I didn't get into the deep on something that more research area. That would be more interesting. Maybe next time we talk about it. So many things that nice to talk. โอเคครับถ้าไม่มีอะไรก็ขอบคุณมากครับ